So composite functions are when we put two functions together. We compose a new function from two separate functions. This is from number 10 on the homework in 6-1. So this one we have f of x is 8 over x minus 9, and g of x is 3 over x, and we want to find f of g, g of f of f, and g of g, and we also need to state the domain of each separate function. So let's start first with f of g of x. So to find f of g of x, we need to take g of x, the inside function, and plug it into f of x. So we have 8 over, instead of x, we're going to write 3 over x minus 9. So we have 8 over 3 over x minus 9 is what f of g of x is. So if now we need to just simplify this. So we have 8 in our numerator, and the denominator 3 over x minus 9x over x. We're just finding a common denominator. So we have 8 over 3 minus 9x all over x. Now remember, when we multiply or divide fractions, we multiply by the reciprocal. So we have 8 times 3 minus 9x, which is 8x over 3 minus 9x. Okay, so that's f of g of x right there, 8x over 3 minus 9x. Now we need to find the domain. So to find the domain of f of g of x, we first find the domain of the inside function of g of x. So the domain of g of x is 3 over x. So x cannot be 0 because we can't divide by 0. And then the domain of f of g of x of our new function is the other one we need to worry about. So 3 minus 9x cannot be 0 because we cannot divide by 0. So negative 9x cannot be negative 3, and x cannot be 1/3. So we have to include both of these in our domain. The x cannot be 0 and the x cannot be 1/3. So our domain of f of g of x is the set of all x's such that x is not equal to 0 and x is not equal to 1/3. We don't have to worry about the domain of f of x by itself because we're not evaluating f of x by itself. We're evaluating f of g of x. So we're evaluating g of x and f of g of x, but not f of x by itself. Okay, the next part, g of f of x. This time, we're taking the inside function, f of x, and plugging it into g of x. So g of x is 3 over x. So now we have 3 over 8 over x minus 9. So again, we flip the denominator upside down and multiply. So we have 3x minus 27 over 8. We just distributed that 3 through that denominator, or the numerator there. And now we have to find the domain. So the domain of f of x, our inside function, f of x is 8 over x minus 9. So x minus 9 cannot be 0. So x cannot be 9. And then our domain of g of f of x right here. The denominator here is 8, so all real numbers work for that one. So we have, for our domain of g of f of x, a set of all x's such that x does not equal 9. And that came from the domain of f of x, our inside function. Okay, 2 more. So f of x. Now we're just worried about f of x. We're not using g of x on this one. So we have f of x. So we have 8 over, now instead of x, we're plugging in f of x. So 8 over x minus 9, and then minus 9. So in our denominator, we need to find a common denominator for the fractions in our big denominator. So we have 8 over x minus 9 minus 9 times x minus 9 over x minus 9. So we need to simplify all that. So we have 8 in our numerator, then we have 8 minus 9 times x minus 9 all over x minus 9. And we can, again, we can flip our denominator upside down. When we divide by a fraction, we multiply by the reciprocal. So we have 8 times x minus 9 over 8 minus 9 times x minus 9. So we have 8 in the numerator, 8 times x minus 9. In the denominator, we have 8 minus 9x plus 81. And we're going to simplify that denominator. I guess we could simplify the numerator also, but we don't really need to. So negative 9x plus 89 in our denominator. Okay, so this is f of x. So nothing is going to cancel out or anything. So this is simplified all the way. So we have f of x. Now we need to find the domain. So the inside function f of x, the domain of that is that x cannot be equal to 9. We've already talked about that. And the domain of our composite function now. So we know that negative 9x plus 89 cannot be equal to 0. So negative 9x cannot be equal to negative 89. Divide both sides by negative 9 and we get x cannot be equal to 89 over 9. So our domain is the set of all real numbers, the set of all x's, such that x is not 89 over 9 and x is also not 9. Okay, so this time we had f of x. So the domain of f of x, the inside function, was important, and then the domain of our composite function. Okay, last one, g of x. So we have g of x is 3 over x, but instead of x, we're plugging in 3 over x. So again, we flip our denominator upside down and multiply. So we have 3x over 3, which is x. This one was a lot simpler, which was kind of nice. So now we need to worry about the domain. So the domain of g of x, that's our inside function for g of x. The domain of g of x is x cannot be 0 because the g of x is 3 over 0. That would be undefined. And then the domain of g of x, this one right here, well, the domain of f of x equals x is just all real numbers. So we don't need to worry about that. So our domain of g of x is just the set of all x's such that x is not equal to 0. So to find the domain of a composite function, you need to worry about the domain of the inside function and then the domain of the composite function and combine those two together.